Hello world and welcome. I'm Rick, and today I'm going to be talking about the BASIC programming language. Specifically, why BASIC mattered and perhaps still matters as a tool to learn programming. When it came out, BASIC held two important advantages over most of its contemporaries. It was simple and it was immediate. BASIC, or Beginner's All-Purpose Symbolic Instruction Code, to use its full and obviously retronymed name, was, for a time, the lingua franca of a generation of home computers. Developed by Kemeny and Kurtz at Dartmouth in 1964, it was intended to provide a way for less technical people to write programs. It used a command set and syntax based on Fortran 2, simplifying where possible. In the introduction to their book, Basic Programming, they explain that the language is primarily designed to be simpler and easier to use than other programming languages of the time. They also state that it is designed to facilitate communication between man and machine. Or to put it another way, it was intended to respond more immediately than contemporary languages. BASIC is an interpreted language, meaning that the statements in the language are executed as they are parsed, stopping immediately when an error is hit, and in that way being able to very clearly communicate what it was doing when the error occurred. When the error is fixed, the program can be executed again, and it will either run to completion or until it hits another error. Compare this to most programming languages of the time, and indeed even now, that are compiled. With these, the program is passed through a compiler that can detect some errors, but not all. If it finds any errors, they must be fixed to complete the process. Once compiled, a program can be executed, and only then will other types of errors show up. When BASIC was introduced, a great deal of computing was done on batch processing systems. In this process, you developed your program offline, handed it over to a computer operator, and they put it in a queue to be run. The program would go through a compiler, and likely the operator would give you back a bunch of compilation errors. You'd fix those, resubmit, and eventually your program would run, and you'd get your results. All too often, those results were, your program had an error, and you went back and figured out a fix, and then submitted the updated program to be put back in the queue, hopefully without introducing any new compilation errors in the process. It was tedious. BASIC was meant to be run on time-sharing systems, where the user was able to directly access the computer running the program. This eliminates the computer operator, and the user no longer needs to write their program offline. With a BASIC program on a time-sharing system, you typed in your program, ran it, got some errors, fixed them, ran it again, and kept doing this until it worked. Feedback and the ability to adjust your program were much more immediate. Since BASIC was interpreted and it did not need a compilation step, it wasn't long before BASIC was running in environments where you could execute basic commands without even having to write and run a program, making it even more immediate. The original BASIC language provided a pretty simple set of statements, some functions, and the means to put them together into a program. BASIC programs require that each line of the program start with a line number. Line numbers were mostly executed in order. It handles variable assignment with the let statement. And variable names in the original BASIC could be a single letter, a letter and a number, as in a single number between 0 and 9, and a variable could also be used to hold an array of values with either 1 or 2 dimensions. The values you could assign to these variables was originally limited to only numbers. These were assumed to be real or floating point values. BASIC also supports a scientific notation using E+ or E- to indicate the power of 10 to multiply by. Let's run through the rest of the original statements. Print to display text and importantly variable values to the terminal. Goto to redirect program flow to a new line, possibly skipping lines ahead or even going back to previous lines. Rem to add comments or remarks to the code. If then provides conditional flow into the system. It acts like a goto, except it will only redirect to the specified line if the provided condition is true. For is BASIC's looping statement. You assign a variable to a range of values from a starting value to an ending value. You can also provide a step increment, which can be negative to count backward. Next indicates the end of a loop starting with for. The loop will stop processing after the for's end value is reached. Data provides a way to introduce a large amount of values into a program. Read is used to read those values and data statements into variables. Restore resets the data, meaning the next read will pull from the first data statement in the program. GoSub, like GoTo, redirects the program to the given line number. However, when the return statement is reached, the program will resume execution on the statement following the last GoSub executed. Def allows you to define your own custom functions. Dim sets the dimensions of an array. This includes setting up two-dimensional arrays. And finally, End stops the program. This became optional, but in original BASIC, a program had to have an end statement. BASIC supports 5 operators, the standard 4 arithmetic operators, and the exponentiation or to the power of operator. It also supports a standard set of comparison operators, used in the conditions of if statements. A set of 11 common mathematical and geometric functions were provided as well. And lastly, the BASIC timeshare environment offered a set of commands to serve as a simple operating system to write, run, store, and retrieve your BASIC programs. Not too long after BASIC was introduced, a few improvements were made. One was to make the let statement optional for variable assignment. Another was to add variables that could contain character strings. These put a $sign after the variable name to denote it. As a kid programming in BASIC, I read these variable names as A string and B3 string. I think many BASIC programmers did. I was always a little confused when my brother, who was years ahead of me in his computing journey, said something like $. With string variables came string constants. BASIC already had these because such strings were commonly used in print statements. Now they can be assigned to a variable as well. And in a huge improvement, an input statement was added to get values directly from the user and make programs interactive. So that is where BASIC started. Where did it go? BASIC quickly became popular on time-sharing systems, and then jumped to mini-computers, and finally microcomputers, following the trend towards more access to computing power in smaller packages. The first product of Microsoft was a version of BASIC that ran on the Altair 8800 home computer, which was more accurately a box of switches and lights, though it could connect to a teletype or terminal. As new personal computer platforms came along, BASIC came along with them. On PowerUp, BASIC was ready and waiting to be used on a massive number of home computers in the 80s. This was the heyday of BASIC, and it lasted about a decade. By the early 90s, the simple BASIC-powered home computer was being replaced by either IBM clones, whose primary purpose was to run applications written by others, or first-generation graphical user interface computers like the original Apple Macintosh and the Commodore Amiga. It is true that you could get Advanced BASIC, or BASIC A, on IBM's, and GW BASIC for IBM clones, and I remember Amiga BASIC being touted when the Amiga was introduced. Even the original Macintosh had a BASIC available to it, but these were no longer front and center to the operation of the computer. It was all about the OS now. With this generation of GUI computers, and soon Microsoft Windows on the PCs, interaction with your computer was all about mouse and click. Typing in a program was so 1980s. BASIC itself took on a new form with the introduction of Microsoft Visual Basic, or VB. VB was component-based visual development, and the actual programs were a combination of component definitions, action flows, and underlying scripts triggered by these actions. A form of BASIC was used to write these scripts. Visual Basic became pervasive in the Microsoft ecosystem, and Visual Basic for Applications, or VBA, was introduced as the scripting language for the Microsoft Office suite. VB was really the last hurrah of BASIC as a mainstream programming language. In fact, it could be the only time that BASIC could be considered a mainstream programming language. BASIC works best as a language for hobbyists, and all of the modern incarnations, and there are many, are at best attempts to provide a language that can teach basic programming concepts. In general, however, these are mostly just a form of nostalgia from a generation of developers who long for the old days when turning on a computer put you in a place where the first action you were expected to take were to tell the thing what to do. So let's look at Hello World. In BASIC, it is about as easy as it can be. There it is, one line, one statement. Want to see it execute? Here it is running in Chipmunk BASIC on a modern Mac. And here it is on the Commodore 64. And here's the Apple II, and in BASIC A on the original IBM PC. Here it is using the original BASIC on an emulated Dartmouth timeshare system. Remember, I said this required an end statement or it wouldn't run. Sadly, this emulator has stopped working, though it remains up and maybe someday someone will get it running again. So what was BASIC's value as a programming language? BASIC in its early forms was, well, basic. But it had the key things needed to write a program. You can store values in variables, you can do math, you can loop, you can handle conditions and branchings, and you can get input and provide output. In addition, it provided a rudimentary way to build some repeatable code segments via subroutines, and offered a way to do a form of mass assignment via data statements. Commands are well named, and the syntax is English enough to be reasonably readable. Let's stop a moment to say that almost all programming languages, and certainly all mainstream ones, have a basis in English. This is not necessarily a good or a bad thing, it is just a thing. But setting aside issues of language snobbery, a computer language that flows and reads like a natural language has significant advantages in explaining itself, even to those well experienced in writing software. BASIC is a language most people can pick up quickly, and its core set of commands is simple and largely consistent across many incarnations of the language. But it is hardly a good programming language. In its most common form, it is not a language that would do well for writing large and complex pieces of software. It is best suited to small projects and hobbyists. So is BASIC all you need? No. If BASIC isn't the best programming language, is it worth learning at all? This is where the debate can get rather heated. Many people, myself included, got their start in software by writing programs in BASIC. Through the 90s and early 2000s, practically every single software engineer was coming from a starting point of typing in BASIC on the first generation of personal computers. Therefore, BASIC is, for a portion of the software development community, a subject of nostalgia. I won't deny it holds that place with me. There are a number of programming languages designed from the ground up to teach people how to write programs. Some, like Logo, have been around for a long time and gone through many revisions. Others, like Scratch and Grace, are still finding their footing. Personally, I'm not sure how interesting they are. I'm sure they're fine. At one time, because it was practically everywhere, BASIC served this role, and for some, that was a really bad thing. Quite famously, Edsger Dijkstra, a pioneer of computer science, railed against BASIC, saying, "It is practically impossible to teach good programming to students that have had a prior exposure to BASIC. As potential programmers, they are mentally mutilated beyond hope of regeneration." There has been much debate about this quote. Some claim he was specifically referring to the original Dartmouth BASIC and not more modern versions of the language. According to such apologists, these versions are much better. I don't really think it matters, to be honest. BASIC is very much a language that works well for hacking things out without much or even any forethought. It has some real limitations in how you can set up loops, and the much-hated goto is a necessity even in the simplest of programs. It is absolutely true that you can learn some very bad habits by starting out in BASIC. Let me offer a counterargument to all that. Who the heck cares? The paradigms of programming languages have seen multiple sea changes over the century or so they have been forming. When Dijkstra was railing against BASIC, it wasn't BASIC specifically. Looking at the original essay, he had a go at Fortran, COBOL, APL, and PLI as well. His argument was that many programming languages force styles of thinking that, in his opinion, were counterproductive to good programming. Let's put programming in quotes, because Dijkstra definitely comes across as a contrarian here. He had a strong opinion about what programming was and what it was not. But it was just that, an opinion. And that's enough talking about some cantankerous but very smart old fart. This space is for me, a less smart but still old fart, to spout opinions. Every programming language will have flaws, and everyone enforces a worldview. Even a wildly freeform language like Perl has a worldview. Tim Towdy. Personally, I think BASIC works pretty well as a starting programming language. From the very start, it provided three main features a beginner needed: a way to get user input, a way to print out results, and a way to store and manipulate variables. This is the barest minimum set of actions required to build some kind of useful program. Ask the user something, manipulate their input, provide a result. Very simple, but you can do quite a bit with just those three actions. Not only can BASIC do these actions, but I think the chosen commands to do them are very understandable. Input, print, let. And yes, let is optional, but for a beginner, it can be a useful reminder of what your intention is. Beyond these fundamentals, BASIC provides simple conditionals, looping, and a means to control flow. With these, a program can be quite sophisticated with a little effort. That little effort is what fulfills BASIC's objective to be simple. But, and this is where I think BASIC works as a good place to start understanding programming, you don't even need that little effort to start putting a program together. BASIC, with its straightforward commands and immediacy, lends itself to experimenting your way to a functional program. You can learn by doing. If you pick up a few bad habits along the way, you'll get rid of them as you learn more and make the transition to other languages. In the meantime, BASIC gives you the key tool you need to start programming, a means to solve a problem. However, BASIC was often called out for its flaws. Dijkstra was hardly alone in his criticism. Let's look at a few reasons why. Line numbers are, by general consensus, terrible. BASIC, in the eyes of many, is terrible for requiring them. For a programmer first starting out, I think line numbers are great. A line number is tangible, it is an automatic label to some action or set of actions, and it explicitly divides a program into steps. Typically, when starting out learning programming, you are asked to solve a problem by breaking it down into some set of logical actions. Then you wire these actions together in a flow that forms the program. The irony here is that the simplest flow of a program is linear, and there is no meaningful difference between describing a program as first get some input, second compute a result from that input, third display the result, and just assigning line numbers. Even the hated goto, so loathed by developers, is an easy concept to get. You label your lines with line numbers, and you tell the computer which line you want it to run next. If you don't provide a goto, it is completely obvious that the next line it will run is the next line number in sequence from where it is now. There is absolutely a time when having to provide line numbers and handling program flow by jumping around between them becomes limiting and frustrating. But that time is not when someone is first starting out trying to figure out how to make a machine do something for them. As BASIC evolved, some variants introduced the ability to have named labels assigned to a line, creating a hybrid where the line numbers were still there, but you could go to or go sub to a meaningful label. Later, the need for line numbers was eliminated entirely. But to be honest, at that point, the language had drifted so far from being BASIC, it may as well have just been another language altogether. Two other complaints commonly levied against early forms of BASIC were the lack of an else for if-then, and the lack of any looping other than for next, and the dreaded goto. Although certainly such constructs would be very useful, to this day I can't see what the big deal is, or rather was, as later generations of BASIC would introduce commands to cover these concepts. In a sense, adding more commands to bring more structure to a BASIC program is kind of missing the point. Sure, it's nice, but it doesn't make the language work any better. The simpler command set was just as capable of performing what the more sophisticated command set provided. Some forms of BASIC couldn't even perform an operation after an if-then, only jump to a new line, like on line 20 here. Sure, it isn't as elegant and certainly not as compact as using an else statement, but it's fine. In fact, I could make the argument that the lack of else actually helps someone first learning to program to think about how a conditional statement breaks down. This old-style BASIC is oddly closer to modern programming languages than the single-line if-then-else statement. Thinking in terms of blocks of code to execute for each case of a conditional is certainly something that can be applied to any form of software development. This can be done with gotos and line numbers just as well as with begin-end or curly braces. Almost any BASIC program is going to have line numbers that, by the numbering alone, create implied blocks, like here, where lines 10 to 60 get things started, then there's a skip, and lines 100 to 130 are a subroutine, and line 1000 starts the main program, and so on. The looping argument is even weaker. The lack of a while statement, or do while or until, does nothing to limit what can be done in BASIC. It might not have the commands do and while, but this bit of code works just as well as a do-while loop. I could even argue that having to write it out this way makes understanding the do-while loop easier when you come to a language that supports it. In BASIC, at least those that require line numbers, do-while is a notational convenience and only becomes necessary when you move to a language without them. Of course, you might need to renumber lines because your code outgrew the line number space you allotted, and that can be quite frustrating. For a beginner, though, that is the kind of thing that teaches important lessons in thinking a little ahead and getting a feel for how much code is needed to solve a task. Such learning can be applied in a future career as a software developer by teaching you how to completely fail to estimate the complexity of your assigned tasks, just like everybody else. One area where many basics did, and some still do, create the grounds for poor programming skills was in the limitation on variable names. The original Dartmouth Basic allowed variable names of a single letter or a single letter followed by a digit from 0 to 9. Many basics on the 8-bit personal computers of the 80s allowed for variable names of 2 letters, but that was it. BASIC also supports explicit variable typing through symbols. So, A is a normal number, $a is a string, A% is an integer, A(5) is an element of the array A. In some flavors of BASIC, all of these, I mean the same variable name but a different type, can exist in a program at the same time. I can't see how that would be confusing in any way, can you? If there was a bad habit that BASIC programmers coming from these limited variable name roots did carry forward, it was almost certainly a tendency towards short, cryptic variable names. Most basics with the 2-character limit did allow for longer variable names where only the first 2 were significant. Occasionally, you might see a program with lines like this. The problem was, if you wanted a variable called age dollar and another called agree dollar, both would end up being interpreted as the same variable, AG dollar. Have fun finding that issue in a program with a few hundred lines. The upshot was that you almost never saw longer, meaningful variable names, and BASIC programmers coming from this era tended to have a remarkable ability to abbreviate almost anything to 2 characters with a wholly mistaken belief that these short names had meaning. Of course, it also didn't help that pretty much every character in a BASIC line that wasn't a keyword was going to eat up memory. The memory available for BASIC program content was very limited. The Commodore VIC-20 had a grand total of 3,583 bytes available, and I had a BASIC programmable calculator that had a whopping 544 bytes of memory. So long variable names weren't just unhelpful, they ate up space you didn't really have. That said, looking back on those early years, many BASIC programs one might write would fit easily into available memory on the common machines like the Apple II, Commodore 64, or Sinclair Spectrum. So why we never adopted a friendly variable naming convention along the lines of 2-character abbreviation followed by longer description as a standard is beyond me. At least that way the code would have had some chance of being self-documenting. Still pretty messy, but at least less likely to end up with age dollar and agree dollar colliding with each other unintentionally. And now I know what each variable actually means. Of course, I am also aware that it took time for BASIC to read in that longer variable name. So this would only work for programs where performance wasn't critical. Then again, if performance was critical, BASIC was not going to be a good option. Thankfully, most modern BASICs will allow long variable names. Chipmunk BASIC, for example, allows variable names to be up to 31 characters in length, and that's a great thing. Before we wrap up, let's look at what I think is the most important BASIC statement. GoSub, or go-to subroutine, ensures that a BASIC programmer can achieve what is probably the most important concept in all of software development: code reuse. The idea that you can write something once and then keep reusing it over and over is a key to making the leap from someone who can put together a straightforward program to someone who can build a real piece of software. It changes the process of solving a problem in software from a series of steps run largely linearly to a series of actions that can be built and tested in isolation and then used over and over. It really changes the way to think about writing a program. But although basic subroutines do help to approach certain parts of a problem as build once, use many, the lack of any form of parameterization of subroutines, again in earlier basics, means their value was somewhat limited. Every variable in BASIC is in the global space. That means all the variables are accessible to all parts of the program all of the time. Each subroutine would generally need a range of variables reserved to serve as parameters to pass in, the local variables to do work, and the variables used to capture the return of the subroutine. With the limitation of 2-character variable names, this kind of reserving of a set of variables specific to a subroutine could really eat up the available variable names. This is where I think BASIC is a little sneaky, and what makes GoSub so important, but I'll come to that in a moment. We've established that BASIC has many flaws. It can lead to some nasty bad habits when moving on to more structured programming languages. It can be frustrating to deal with if you aren't careful. There are those with very strong arguments for having beginners avoid BASIC, which is pretty damning for a language that was intended to make programming more accessible. My contrarian opinion is that the flaws in BASIC actually work to its advantage as a good beginner programming language. And I'm not talking about the fancy basics where line numbers are optional or removed entirely, and subroutines can be parameterized and have local variables. I'm talking about early form basics with all their limitations. These simple basics are accessible. Look again at how Hello World looks in BASIC. How much do you need to explain to someone for them to get everything happening here? 4 concepts. You need a line number for your statements. This tells the computer this is part of a program and where in the program the line fits. The print command prints or displays something to the screen. A message you want to display needs to be in quotes, and to see it, you need to run it. Those are pretty simple ideas to explain and to understand, and it is enough to get a first program written and executed. The fundamentals of the language are in that simple hello world as well: line numbers, command syntax, strings. You could make the argument that the perfect first basic program would be this. In that one statement, you learn a little about line numbering, variables, strings, commands, and flow control. Not many languages have the capacity to teach so much with so little. From this starting point, you can learn BASIC a statement at a time, moving to input and then on to if-then, for-next, go-sub, and so on. Along the way, the person learning is going to run into the flaws and limitations of BASIC. You need to be careful about leaving enough gap between line numbers. Variable names need to be carefully considered and probably documented to keep track of all those 2-letter combos. Flow control can get confusing if you keep jumping around with goto, and on and on. Like what we saw earlier with go-sub. You get code reuse, but the way variables are handled means you have to be careful about the variables you use and change inside that subroutine, or you can create side effects. That is, to me, BASIC's trick as a beginner programming language. So why BASIC? BASIC is a good language to start out with because it can serve the pure hobbyist or dabbler just fine, but the person who is going to be a developer is going to reach a point where they must move past it. Sure, they might have picked up some habits they will need to unlearn, but they've also likely developed some good problem-solving skills and have a keen sense of when the features of a new language would help them do something they railed against in BASIC. And when they do move to more capable and professional programming languages, they are going to see solutions to the barriers BASIC put in front of them. I can speak personally that this is a very freeing experience. Often the best way to understand a feature of a language is to have dealt with the limitations of a language that did not have that feature. In short, the why of BASIC is that it is a very good language to start in, but also a language that very much wants to kick you down the road to bigger and better things. Thanks for watching. This was a long one. What do you think? Was BASIC the first programming language you learned? If not, what was? Do you think BASIC has any relevance today? Do you think it could? I'm looking forward to everyone telling me I'm wrong in the comments.